Hi children, we continue with our chapter Carbon and its compounds. In the previous class, we discussed about saturated hydrocarbons or alkenes. Today's class, we will see about unsaturated hydrocarbons. Unsaturated hydrocarbons. Unsaturated hydrocarbons are hydrocarbons in which there is a double bond or triple bond between carbon atoms. Hydrocarbons which contain a double bond or a triple bond between carbon atoms are known as unsaturated hydrocarbons. So, unsaturated hydrocarbons are of two types, alkenes and alkynes. Alkenes contain double bond between carbon atoms and alkynes contain triple bond between carbon atoms. Okay, so single bond, double bond, triple bond. Single bonded compounds are known as saturated hydrocarbons or alkenes. Here we deal about unsaturated hydrocarbons. Hydrocarbons which contain a double bond or triple bond between carbon atoms are known as unsaturated hydrocarbons. Actually, the double bond and triple bond together are known as multiple bonds. So, hydrocarbons which contain multiple bonds are known as unsaturated hydrocarbons. Hydrocarbons which contain a double bond between carbon atoms are known as alkenes, and the one which contain triple bond between carbon atoms are known as alkynes. So, today we will discuss about alkenes. Alkenes. The hydrocarbons which contain a double bond between carbon atoms are known as alkenes. The general formula of alkenes is CnH2n. We learned it for alkenes, CnH2n plus 2. For alkenes it is CnH2n, where small n is the number of carbon atoms. So, we will write the name and formula as we did it for alkenes. So, n is equal to 1. Is it possible for alkenes? Can we write the compound with n is equal to 1? No, because alkenes are compounds which contain a double bond between two carbon atoms. To put a double bond between two carbon atoms, n is equal to 1 is not possible. N is equal to 1 means there is only one carbon atom. With one carbon atom, we cannot write the double bond. There should be at least two carbon atoms for alkenes and alkynes, because there is a double bond between carbon atoms. So, the lowest alkene should contain a minimum of two carbon atoms. So, n is equal to 1 is not possible for alkene. So, we start with n is equal to 2. C2H2 into 2. So, what is the formula? C2H4. So, under alkanes I gave you the names of hydrocarbons with n is equal to 1 to 10. Meth, eth, prop, but, pent, like that it goes on. So, the same prefix starts here also, but the suffix to be added is ene. So, here it is eth. For n is equal to 2, you have to start with eth. Since it is alkene, we write ene of alkene. So, the name becomes ethene, CnH2n, ethene, C2H4, ethene. Now, what is the structure? There are two carbon atoms which are joined by a double bond. So, C, double bond C. Now, how many valencies are left? Two valencies are occupied, two more valencies are free. Second carbon atom also two valencies are occupied. We have to represent two more valencies where you have to write hydrogens. So, this is the structural formula. How can you condense it and write? First carbon atom C, connected to that there are two hydrogen atoms. So, we write it as H2, bond is double bond C. Then second carbon atom again has two hydrogen atom. So, H2. So, CH2 double bond CH2. CH2 double bond CH2, this is the condensed formula. This is the structural formula. C2H4 is the molecular formula. you have to count and see that the number of carbon atoms and hydrogen atoms match everywhere in the molecular formula, structural formula and in the condensed formula. Name of this compound is ethene. Next, N is equal to 3. C3H2 into 3. So, C3H6. What is the name? Starts with prop. 3. N is equal to 3 is prop. Add ENE. So, it becomes propane. 3 carbon atoms. 1 bond you can write as double bond. You can write a double bond on between first and second carbon atom also. Anywhere you can write the double bond, but 1 bond should be double bond. So, the other bond is single bond. Now, take the first carbon. It's one valency is occupied with the second carbon. 3 free valencies are there where you have to write single bonds. Now, take the second carbon. On the left hand side 1 valency is occupied. Right hand side 2 valencies are occupied. Now, how many free valencies? 1. Third carbon 2 valencies are occupied, 2 more free valencies. So, there you have to write hydrogen atoms. So, this is the structural formula. This is the structural formula of propene. Now, condense it and write first carbon C. Connected to that there are 3 hydrogen atoms. So, CH3, single bond C, only 1 hydrogen atom. So, CH. Next bond is a double bond, then CH2. Okay. So, C3H6. This is propene. Okay. Next, N is equal to 4. C4H8. What is the name? Butene. Name is butene. Draw 4 carbon atom. You make 1 bond, double bond. Any bond between carbon atom you can make double bond. Time being put only 1 double bond. There are compounds with more than 1 double bond between carbon atoms. So, now we have just begun the topic. So, 1 double bond only we will put. Now, the other bond should be single bonds. Take the first carbon. It has 3 free valencies. Second one, 1 plus 2, 3 are occupied. So, only 1 valency is free. Third one also 2 plus 1, 3 is occupied, 1 free valency. Last one, all the 3 valencies are free. So, write hydrogens. Okay, so this is the structural formula C4H8. Count and see. Now, condense formula CH3, single bond C. How many hydrogens on the second carbon? 1. Double bond CH, single bond CH3. Okay, so this is the condensed formula of butene. So, butene is the third member of alkene. First, N is equal to 1 is not possible. So, the first one is N is equal to 2, then N is equal to 3, N is equal to 4. So, this is the third member of this series. Now, N is equal to 5, C5, H2 into 5, making it C5, H10. Name is pentene. Draw 5 carbon atoms. Make one of the bonds double bonds. One of the bonds should be drawn as double bond. So, the other bonds can be single bonds. Now, take each carbon, find out the valencies which are free to be filled with hydrogen. Okay. So, write hydrogens everywhere. I hope you are following. Now, write the condensed formula. First carbon atom, there are 3 hydrogens around CH3. Next is a single bond C, 2 hydrogens on the second carbon H2. Single bond C, 2 hydrogens CH2. Then single bond C, only 1 hydrogen on that. Then double bond CH2. So, this is pentene. Okay. Next one, N is equal to 6, C6H2 into 6, C6H12. Name is hexene. Okay. Now draw 6 carbon atoms. Make one of the bond double bond. Anywhere you can put the double bond. It's your freedom. But accordingly the valencies formula will not change. There will not be any change in the formula. Number of carbons and hydrogens will be same. Only the position of the double bond changes. So accordingly there will be adjustment in the number of hydrogen atoms on each carbon. So 3 free valencies. Second one, 3 valencies are occupied. Only 1 free valency. Third one also only 1 free valency. Now mark hydrogens there on the free valencies. Okay, so this is the structural formula. Now we can write the condensed formula. C, first carbon C, 3 hydrogen atoms, single bond C, H, then double bond C, H, single bond CH2, single bond CH2, single bond CH3. So this is hexene. Okay, so the first 5 members of the alkene series we have written. So it starts with ethene, propene, butene, pentene, and this is the 5th one, hexene. Okay, so this is enough for alkene. For alkene we have written 10 members. So here 5 is enough. Now the electron dot structure, we will write the electron dot structure of the first member of alkene series. First member of alkene series, C2H4 ethene. Electron dot structure for ethene. So C, 2 carbon atoms, 4 hydrogen atoms. So first write the combining atoms. Show the electrons of. So carbons have 4 electrons. So I have represented them with cross sign. Each hydrogen atom has 1 electron. So they are represented with dot. Okay. Now make the number of electrons for each hydrogen 2 by sharing with carbons. So all the 4 hydrogen atoms have now 2 electrons each. Now take the first carbon atom. It has its own 4 electrons. First carbon atom has its own 4 electrons. Then the hydrogens which are connected to it has 2 electrons. 1 plus 1, 2. So total number 6. So it needs 2 more electrons which it takes from the second carbon atom. So making the total number of electrons around the first carbon atom 8. Okay. Its own 4 electron. 1 from each hydrogen atoms which are connected to it, and then 2 electrons from the second carbon atom, making the total number 8. Okay. Now take the second carbon. It's 4 electrons. Then 5, 6 from the hydrogens connected to it. Then 2 electrons from the first carbon atom. Okay. Now we can write their structures. What is the nature of the bond between carbons and hydrogen? Everywhere you can see that only one pair of electron is shared. So all these bonds are single bonds. Now look at the central portion between 2 carbon atoms. How many electron pairs are shared? 2 electron pairs are shared. So we write it as double bond. 2 electron pairs or 4 electrons are shared. So this is a double bond. So this is the electron dot structure, and this is the structural formula of ethene. I hope you understood this. So that's all. Thank you, children.